Here we'll look at a second order differential equation. So recall that that means that we're dealing with the second derivative being involved in our differential equation. And in particular, we're having the second derivative of y with respect to x is equal to negative y. In this case, what we're going to need then is, we'll see that it's not enough just to know one initial condition, but we actually have to have kind of two data points here in order to find our solution. So my assumption, yet again, is that y can be represented as a power series centered at 0. And let's just write out those terms again. And I guess here I should use x's if that's my independent variable. So notice that, of course, one big change is that in this particular problem, we're going to have to find the second derivative of y, which we haven't needed yet. So to get there, I need to find the first derivative, which we have seen in our previous examples. And like I said, we'll write down the second derivative. So I'm taking the derivative of the blue equation, which will leave me with 2a2 plus 6a3x plus 12a4x squared plus 20a5x cubed plus the next term would be 30a6x to the fourth, and so on. So I needed the middle equation there to get to my second derivative, but in this particular problem, we're not going to use the dy dx. It doesn't show up in my differential equation. So from the differential equation, what we're going to say is that the second derivative, so the blue equation, is equal to minus y. So I'm going to take the first equation and multiply everything by a negative 1. So minus a sub 0 minus a1x minus a2x squared minus a3x cubed minus a4x to the fourth, etc. So we set these up. Again, I'm going to start with my given initial condition. So y of 0 is equal to 1. I go back up to the pink equation, I substitute in 0 for x. That leaves only a sub 0, and so we see that that has to equal 1. Then the other thing I can do, which I haven't had before, is I have this piece of information. So we're told that y prime of 0 is equal to 0. So we're going to go up to the y prime equation, the blue one, substitute in 0 for x. If we do that, we'll get a1. But we're told that when we substitute in 0 for x, we should end up with 0. So effectively, what having these two initial conditions allows us to do is find two of our coefficients right off the bat. To get the rest of them, that's when we start matching coefficients. So that's where I'm going to come down to this equation here to look at the like terms. So to start with, I'm going to equate the constants on both sides. So that gives me 2a2 equals negative a sub 0. So that means that we get negative 1/2 for a sub 2. Then if I look at the coefficients of x to the first power, we're going to get 6a3 equals negative a1. But a1 is 0, so that means that a3 is 0. Then I can look at the coefficient of x squared. That's going to give me then 12a sub 4 equals negative a sub 2. So negative a sub 2 is negative 1/2, or times negative, that's going to get rid of that, make that positive 1/2. So a4 is 1 over 2 times 12. To find the next set of coefficients, we're going to set 20a5 equal to minus A3. A3 is 0, so A5 is 0. And notice the way this is going. A7 is going to be dependent on A5, so that's going to be 0. A9 will relate to A7, so that will be 0. So basically, A sub k is going to be 0 for all odd k's. And then I'm left with, for what I've written here, one last one to kind of test my pattern on. We're going to get 30A6 is equal to minus A4. That'll make this a negative again. And I've kind of been simplifying where I said I wouldn't before. Maybe writing it here, we can see that 24 is 2 times 3 times 4, and 30 is 5 times 6. So this is actually 6 factorial in the denominator. This is likewise 1 over 4 factorial. This is negative 1 over 2 factorial. And if we want to come back up to a sub 0, we get 1 over 0 factorial. So what I can notice here is that if I want to write out my terms, this one I have that the odd k values, a sub k is 0. So we have y is the sum of a sub k, x to the k in this case. And if we start to write out terms, we're going to get 1, and then x to the first power has coefficient 0. So then we get 1 minus x squared over 2 factorial. The x cubed term has coefficient 0. So then we get this. X to the fifth term has coefficient 0. And so we get this pattern. I could put this in sigma notation. You wouldn't have to answer this, but if I put this back into sigma notation, notice that I could get rid of the odd k's by putting in 2 k's and then get the alternating term like this. But whether you put it in sigma notation or leave it in this written out form here, hopefully this looks familiar. And again, much like our first example, this is exactly this Taylor series of a familiar function, and that function is cosine of x. And so again, using this technique, we're able to get to that. And we haven't really dealt with too many differential equations that went beyond the first derivative. But the point is, if I start with the assumption that y is this sum of powers of x, then I can find the second derivative of that and still go through this technique of equating those like terms.